Hi there, welcome back. Well, we've got quite a bit done, but it's not quite there yet. The first thing I did was I started doing a bit of a cleanup of the front panel because some of the testing requires the front panel to be in place. What I normally do is I put them in some warm water with dishwasher liquid for a while and then get an old toothbrush, scrub them down, then dry them. It tends to work quite well. The front panel I just wash with water and some detergent, very mild. Be very careful, you don't want to remove any of the labeling. So that's complete. The next stage was I did replace the capacitors. The big caps did arrive. Unfortunately, they're not particularly good quality caps, but I put in what I received. They're the right values, and they're actually quite accessible. So I can always change them when I get the Nishikons that I ordered as well. I also did try to reroute some of the cabling, put them into the cable holders. It is not perfect. To do that, I would have had to cut all the cable ties. And in my experience, when you do something that dramatic, you better get ready to break some cables or have to re-diagnose the problem again. Now, I might do that afterwards, but for now, I've improved it quite a bit. But it's not perfect. Now, what else have we done? The IF amplifier board was replaced in its position. The tags that tighten it down, which is the metal tags you got to bend, I did just 2 of them very gently because I think that's what might have cracked the board in the first place. So that is done. So I think cosmetically and physically, mechanically, I think it's all there. What I still haven't got is shortwave, but before I worry about that, which could just be a switching problem, I'm going to tackle some of the alignment steps, some of the adjustment steps. And the first step, of course, is to make sure that the voltage regulation is working properly. Now, I know that the service manual, which I've received a couple of translations for, and I'm updating that, it does start with FM alignment. That tends to be the one I do last. So I decided to just do it in my own order. And the first order of business will be adjusting the voltage on the voltage regulator. And to do that, we just connect the voltmeter to the emitter of that pass transistor. Switch it on. And what do we get? Not bad, not quite there. So let us adjust it. Small screwdriver into the pot. Got to do this very gently. And adjust it till we get it just right. That's pretty good. Now we need to measure the 15 volt rail. We need to find about 15 volts on there. That'll depend a little bit on that diode that I changed. So we're on 14 point. Yeah, that's good. That's good enough. Perfect. Time to move on. On with the alignment, and I'm going to do the AM alignment first. The AM IF alignment first. Okay, so here we have the instructions for the alignment of the AM IF amplifier. We're talking about aligning this for the intermediate frequency, which is 455 kilohertz, of the AM circuit. Now they tell you to select medium wave, put the frequency setting on about 1400 kilohertz, preferably somewhere where there's no station. Then you connect a sweep generator. They say sweep generator and marker. We'll get to that in a second. 455 kilohertz small signal through a 10 kilo ohm and 10 nanofarad capacitor. Now this 10 kilo ohm, 10 nanofarad is basically just to isolate the signal from the point you are connecting it to. Display unit on 7, we'll get to that as well. And then you've got all these to align. And they say filter 202, 301, 303, 304, and 306. The way you do it is you're trying to align these filters to allow 455 kilohertz to go through as clearly or as strongly as possible. And then you get to a point where you need to sort of widen the bell curve that I'll show you in a second, so that you have the minus 3 dB points. You have a band spread of about 2.5 kilohertz. It's really the pass bandwidth. Let me show you what I'm talking about. On the schematic, if we draw it up like this, we can see quite clearly what they're trying to achieve. Point 4 is actually the base of the mixer transistor, and that's where they tell you to inject the signal. The signal we're going to inject we'll discuss in a second, but you inject it in here, the signal goes through here, and it meets the first filter. And this filter has to filter everything else out except 455, which is the IF frequency, which is a carrier that is carrying your audio information. In other words, your station, the audio, the music, the voice is modulated on 455 kilohertz, which is the result of the mixing between the front end frequency that you've tuned to, let's say a 1 megahertz station, and your oscillator, which will produce 1455 kilohertz. They mix, you take the difference is what you want to get through, so you've got 455 kilohertz. It comes out of here, through there, up there, and it goes to that section over there. Now before that gets amplified again, you again filter it out. In other words, you again put a filter in to make sure that what gets through is 455 kilohertz. So you've got to tune that filter as well. It then goes through to that filter 303, which is coupled to filter 304, and you do the same here and here. And at this point, you're starting to worry about what the shape of the curve is. You don't just want a maximum peak. You want to make sure that it's got a bit of width to it as well, and that it is symmetrical along the axis, which I'll show you. It then goes through another amplification stage, and it gets to the final one, which has the detector on it. And this is the one where you really have to focus on getting the right shape. If you modulated your carrier with an audio tone, you could hear it over here. But we're not worried about the modulation. We're worried about the strength of the carrier signal. Because what you have here, at this point, when it goes through the diode, it rectifies the signal coming through here, and it extracts two things. One is it extracts the audio, and the audio actually comes through here and then goes to the selector switch, but it also creates a DC voltage which is proportional to the signal strength. So the stronger the signal, the bigger the DC voltage. If this was a tube radio, this DC voltage would be negative, it would be the AGC voltage. In this particular case, it actually works out as a positive voltage. But that doesn't matter, you just want the amplitude of that voltage. And that's what you're going to measure to tell you how strong the signal is, or how clear it's getting through those various floodgates that you want to tune for 455 kilohertz. So we are going to measure this here. And you could do it as a one-off situation. In other words, you could feed 455 kilohertz at the other end and see what the strength was that you got here on a multimeter, and you could adjust the filters to give you the highest signal, but it wouldn't give you an indication of the shape. Now what we're doing here is what we normally do just by measuring the AC voltage of the audio tone when you want to do it, align it using the audio, but we're doing this aligning basically the AGC voltage, which is what's happening here. Now, what we're trying to achieve is a curve, and that curve has a few characteristics. The curve that you actually want is something like this. It'll be a bell curve which will be low amplitude at lower frequencies. As it approaches 455, that amplitude starts getting higher. So if you had a 450 kilohertz signal, it'll be somewhere up here. As you get closer to 455, it should peak, and then as you exceed 455, it should come down again back to call it a 0 point. It's not quite zero, but the base point over here. Now that's what you want as a result of all the filters. Now the reality is something different. When you first get in there, you won't really see this. When you get to the first filter, this is what you might find. So when you align it, when you tune it, you want to tune it to there. Now the way to do that is you feed a sweep from your signal generator a signal that starts at a certain frequency and ends at a certain frequency. Now what we know is we want 455 in the center, so we'll start, say, at 20 kilohertz below, which is 435, and we'll end the sweep at 475, which is 20 kilohertz above. Now when the signal starts at 435, it's being attenuated by the filters, and as it gets to 455, you want it to be the strongest signal over there, and then it starts going down again. So when you tune the first filter, you're basically making sure that the frequency that's getting through the strongest is the 455. Then you get the second filter, and that might be something like this. So what do? Well, you've got to align it again. You've got to align it again to make sure that it is exactly in line with the first filter you've aligned. And it looks easy like this, but you're actually looking at the combination of all the filters in line. But this is what you're doing. When you get to the next filter, let's say that it's over here, well, you align it and you get it in line as well. And then you get to the last filter and it is, say, over there, so you align that as well. And the result that you see is actually a combination of all these. It's the sum or the cumulative effect of all these filters going through, and you will get something like this. And the reason you see a stronger signal is that there is amplification in between. They're not exactly the same level, and it sort of sums up because you got the signal being amplified. It's not quite centered. There we go. That's what you get. Now, what you want is you don't want this thing to be particularly peaky. You actually want this curve to have a little bit of depth over here, a little bit of width. And the reason is you want your audio signal to fit nicely within that span that is called the 3 dB point. In other words, if this thing was a very sharp line all the way up here, you'd get a very strong signal, but you wouldn't hear very well because the audio wouldn't have enough width of frequency to actually get through. So you want a bit of span. And basically the trade-off between how high this is and how wide this is where you are selecting between quality of sound, in other words, fidelity of sound, and sensitivity of the actual receiver. Now, in our situation now, when we listen to AM, and remember this is for the AM bands, we don't exactly expect hi-fi music to come through. It's probably more important to have it highly selective, in other words, very sharp, very strong signal, not so much the wide signal. We don't have a lot of local stations, so we need as much strength on the signal as possible, not so much the width, but you still want to give it some width. And that width is what they give you in the last instruction. They say 3 dB point, 2.5 kilohertz across. And that's what they're telling us here. If you measure the total amplitude from that point, and you get a 3 dB point, which is minus, it's at 0.707 of that total amount, and you cross those lines over here, what you want between the two is about 2.5 kilohertz. Now, if you don't get that, there are ways of working around it. And one way of working around it is to do what is called scatter tuning. And when you scatter tune, what you're doing is you're actually taking one of the filters, tuning it a bit to the left, and you're taking one of the other filters and tuning it a bit to the right. And what happens now is that this main curve in the middle is going to be wider. It's not going to be as strong, but it will be wider. So basically what you've done is you've weakened your sensitivity. This thing is shifted off a bit, never mind. But you've made it wider, and you've made it able to receive a bigger span on that 3 dB point. It is a trade-off between quality and sensitivity. And what I normally do, is I try and get a combination of both, but more on the sensitivity than on the bandwidth. I just wanted to show you what it is I'm going to tune. When I talk about feeding a sweep, you now know what I'm talking about. And when we tune the filters, what we're doing is we're getting them all aligned to that center frequency so we get as strong a signal in the middle as possible. Okay, let me set this up and I'll talk you through it. First thing to do is to set up a signal generator. I'm setting up at the minimum signal that I can. We'll then alter that as needed. This is at the moment on the base frequency, but that's not important because what we're going to do is we're going to use a sweep. Now that's the sweep function selection there. I want a linear sweep, not a log sweep. So linear. I'm going to start at 435 kilohertz. I'm going to end at 475 kilohertz. And time, I don't know, 100 milliseconds. We can change that as needed. The time base you use, the time of the sweep, actually will affect the response time of the curve. So if it's too fast, it'll probably be a bad response. If it's too slow, you'll probably get too much noise. But we can test that once we've got this thing going. And the trigger, I want the trigger out on the downward slope. And the reason for this, we'll see when we get to the scope. I'm taking the trigger signal from the back. And the trigger signal is a square wave that indicates the start and the end of the sweep, and then it starts doing the wave again. So that is all set. The signal comes out of the signal generator. It's connected to ground on the chassis. The other one goes through a 10k ohm and a 10 nanofarad capacitor to 0.4, which I've soldered it to, the base of that transistor, as indicated in the instructions. The 10 kilo ohm and the 10 nanofarad acts as a isolation for DC, but also it creates a bit of a load so that we don't pull that down too much. And 0.7, if you look at the schematic, is actually 16th pin on that connector there. So you could actually solder a little tag to the pin 16 over there. What I've done is I've actually followed it back and I've soldered a tag to a more convenient point, which is a pad over there. And I've connected the scope to that. As instructed, I'll select medium wave. I'll set the receiver around here on 1.4 megahertz. Then we just need to switch it on. Okay, I've got the sync signal from the signal generator going into channel 2. I have the trigger set to channel 2. In other words, this sync signal, which is a square wave, is triggering the scope. If you look at the period of this signal, let's say we start here, it goes up, across, down, across, and then the new wave starts again. So if we count this, we've got 1, 2, 3, 4, 5. That's 5 divisions for a full wave. And 20 milliseconds per division means we've got 2, 4, 6, 8, 10. That's 100 milliseconds. That has to do with the time base that I've set on the signal generator. Now if I change that to 200 milliseconds, that's now widened up again. As you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 at 20 milliseconds. We've got ourselves a 200 milliseconds period. Now, what period do we want? Well, we want this entire thing to fit on the screen, just to make it convenient. So it actually works better if I make it, say, 120 milliseconds, and then I can drop there. I've got 12 divisions on the scope, 10 milliseconds per division, that's 120 milliseconds. Or I could make it 60 milliseconds. Yeah, 5 milliseconds per division. I've got the entire wave on here. If I go just one left, you can see I'm fitting 2 on there. So that's what I want. The other thing is the question of whether it triggers on the downslope or upslope. In other words, whether the start of the curve is on the downslope of this. Let's just get that back. If I make the trigger on the downslope, it means that when that sweep starts, in this case at 435 kilohertz, the trigger goes down. If I make it on the upslope, it means it starts there. Now, because I want this section in the middle, I'm going to make a trigger on the downslope. Get that back to where we want it, which means that the sweep actually starts here, right? It starts going up, 435, 440, blah, 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 blah. When it gets to here, it's at 455 because it's in the middle of the sweep, because it carries on to the end of the sweep setting. So we know that the center of the scope here is 455 kilohertz. And that's very, very important, so that you know, because we don't use a marker, we know where the center is. Now, if we had a marker generator, we would just feed a 455 kilocycles or kilohertz signal to combine with the IO frequency that we're sending in, with the signal that we're sending in. And that would always blip away there. It'll sort of tick away there at the 455. Then it doesn't really matter where you are, but this is more precise in my opinion. Now it's just a question of switching on the dim bulb tester and see what we've got on channel 1. That is our response curve. That's not bad, actually. That's not bad at all. I can now hide channel 2. And what we're seeing here is we're seeing a response curve based on the frequency that's coming in. At 435, it's getting attenuated quite a bit. It goes along and then it starts getting through. At 455, it's getting through the most, actually, and then it goes down again. Now, what we're seeing here is that the center frequency is not quite on 455. It's actually on where? That's 455. That is, we're talking about 20 kilocycles below and 20 above. So this is about 3 each. I'm going to change this to 12 below, and I'll tell you why. If this is 455 and I make each one of those divisions 2 kilohertz, it'll make it very easy for me to determine where we are. So 455 minus 12, let's go back to start, is 443, is it? 443. Now obviously it's shifted because I haven't changed the top one, and 455 plus 12 is 467. There we go. Now we are set. So I now know that each one of these divisions is 2 kilohertz. So I know that my center frequency at the moment, there's 455, there's 457, it's on 456. It's actually set to 456. So it is slightly off. So what I'm going to do now is with this absolutely amazing and multifunctional chopstick. It uses, I've just filed the end there. I'm going to start on the filters, and I'll do filter 1, 2, 3, you know, in the order that I showed you in that drawing, and see if we can improve it. So, first one. Whoa. That's shifting towards higher frequency. Let's go to the next one. We're sort of shifting it left. That's shifted it nicely. That's shifted it probably a bit too much. Now we get to the last one. Nope. It's changing the shape. We want a sort of a flat top. Let's see if I can't get a bit more amplitude out of there. Wrong way. going back on those filters, on the coils. Whoops. That's a very sensitive one. Now that seems pretty good. But I do seem to have dropped the amplitude a bit. I'm just messing with the top one again. The last one. The last one gives quite a bit of amplitude. Second to last. You see, I'm not getting much symmetry. That side is higher than that one, which is not supposed to be. But we'll correct that in a second. Back to the last one, that's filter 306. That's the one I realize I can shift the shape. You know what? I'm happy with that. I'm happy with that. Now, let's see if we can do some markers here. Can't use it in this mode. Now, if we had the markers, we'd be able to work out the 3 dB point a lot easier. But if we just set this, let's call that there the maximum. I've got 200 millivolts per division, so 1, 2, 3, 4, 5, call it 5 divisions. 0.7 is 4 point something divisions, so it'll be 1, that's 0.8, that'll be 0.7 over here. About there. Now, what they tell me is they want at least 2.5 kilohertz band spread on there. And what do we have? We've got 2.5 kilohertz either way, which is about right. I'm actually not sure whether they mean 2.5 kilohertz from there to there or from the center to there. I think it's from the center to there, because when this thing is decoded, it basically rectifies, and I think the bandwidth that you want is from the center to the end. So in other words, 5 kilohertz across. That's pretty much what we've got here. In fact, it's exactly what we've got here. If you take that point there, each one of those is 2 kilohertz. So 2 kilohertz on there, 2 kilohertz on there, and a bit more, 2.5. I think that's our 2.5 kilohertz either way. I might be wrong. This might be supposed to be 2.5 across, which means 1.25 to each side. I'm really not sure, and maybe you can enlighten me in the comments. But basically, that's our response curve for the AMIF done. And it's a pretty nice curve. I mean, it's nothing to do with the drawings you do in Photoshop. It's a bit noisy, but that's the way it is. And if you mess with the tuning, and if you happen to come across a station, a strong station, this hasn't got an antenna on, obviously, you could actually mess this up even more. So I'm actually pretty happy with this result. That's the AMIF aligned. And now I want to test it and see if it has improved its sensitivity and if I've got shortwave at all, which is still the problem I have to face. Anyway, I hope this description of the AM alignment with the visual method works for you. There's another way, in fact, there are various ways you can do this. And I prefer this one because you can actually see it. In some cases, it's not as accurate as this. This one actually did a very nice job. All right, onwards. Now, the next stage I'm going to do is the AM front end alignment, starting with the long wave. If we look at the instructions, it says AM input, long wave oscillator. And you go and set the signal generator at 150 kilohertz. That's the carrier signal. You've got to do a modulation, AM modulation, depth of 30%, 1 kilohertz tone. Now it tells you to send it through a dummy antenna, which is in this case basically a 400 ohm resistor in series with a 200 picofarad capacitor. I've got the next best thing. It's a 390 ohm resistor and a 220 picofarad capacitor. So the signal generator feeds into there, and then it goes out the other end into the antenna socket for the AM. And the point you got to read from is again point number 7. And I found a convenient spot on the top side to connect the probe to. And I've got this multimeter, this meter on AC volts connected to that point. Now all we're trying to do is to make sure that when we tune to 150 kilohertz, we actually get 150 kilohertz. So we're sending 150 kilohertz signal, and we have to see whether we tune it at exactly 150 kilohertz on long wave band, as you can see there. Now the first thing I normally do is I see where it is strongest, and I've actually got the audio on so we can hear it. Now I've got this on exactly 150 kilocycles, which is over there. And if I tune it away, it's gone. But if I tune it this way, it gets better. So it's actually there. So it's slightly off. It's that much off. So what I'm going to do is put it on the 150 again. And then adjust coil LO6 to get that on max. Now coil LO6 is damn near invisible. It's under there, and the way to get to it is through this one here. That's why it's got these holes on here. In fact, I think it's that one. So we'll check the meter, and I'll do the alignment. We'll see what improvement we can get. Here we go. Wrong way. That seems to be the maximum. So we've done that end. Now if we look at it and listen to it, goes off, slap bang in the middle, 150. Now because this is long wave has a pretty broad band, so it doesn't disappear straight away, it fades away, but it's pretty well tuned. Now the next thing is to go to the top end, and the top end is 320 kilohertz. Let's tune it there and see what we get. Again, it's slightly out. I would say the peak is over there. It's at about 310, so we've got to peak it at that point. That's almost at the end of that band. Alright, do the same. Now what we need to do is adjust capacitor C225, which is right next to that coil that we just saw. And we'll peak it again. Wrong way. That seems to be it. Now if we look at the field strength meter, let's just put the tone down. I'm on 320, move away to the right, it dips. 320, move away to the left, it dips. So we've got that aligned. Now I'm going to go back to 150 on the signal generator, and we'll tune down to 150, see if that's still in place. just slightly off. I'm just going to adjust it slightly. You have to do this a few times, so I'll do this a couple of times and then we'll have this thing done. What we see next is we're actually going to align the antenna section, the front end section. What we've just done is actually the oscillator calibration. And what we need to do is set it to 160 kilohertz and do the same thing. So you set this at 160, you inject a 1000 hertz modulated tone into the antenna through the same dummy antenna, and you adjust coil LO203 for a peak at 160. This is just to make sure that the front end is tuned in to allow the best reception through. And then you set it to 300 kilohertz and you adjust capacitor to 10. This time it's actually that bugger over there and the capacitor in front. Okay, let's see if it makes any difference. Yeah, we've got a bit more there. No, wrong way. Well, that's a peak. That's a peak. Okay, now we've got to set it to 300 kilohertz and do the cap. Let's see what we get. So I've set the signal generator and the receiver to 300 kilohertz, and now I'm going to adjust that cap. No. No. Looks like it was peaked right there. So we've done the front end alignment for the for long wave. The next step is the medium wave oscillator, and here they tell you to tune it to 515 kilohertz and align it with L205. So let's do that. Set it on medium wave, tune in 515 kilohertz, and we'll see how far off we are. Now I'm approaching it and I get a peak there, but I think the alignment point is actually over here. Sorry, over there. That's 550, and for some reason there's a little notch on the dial there. I think that's the alignment point, but we're a little bit off, so I have to move it to there, which is what I'll do next, and it's with coil 205. Now that coil is actually achieved through that hole here. It's right next to the long wave switch. It's a red one. You can hardly see it, but I'll have to put the alignment tool through that hole and we'll see the result. Okay, let's start adjusting it. Ooh, okay. That's about a peak there. Now, of course, we're going to do the medium wave at the top end, 1.6 kilohertz, and we adjust C224 to max. There, I'm just approaching it, and you know what? I'm looking at it from the front. That is exactly right. 1.6, no adjustment necessary. Hooray! Now we've done both the low end and the high end oscillator alignment for medium wave. We need to do the front end for medium wave, which is next. The medium wave front end, they say you set it to 570 and you adjust coil 202. You set it to 1.5 megahertz and you adjust capacitor 209. Okay, tuned to 570. Ready to adjust coil, what is it? 202. That's the front end. Oh, bloody hell, wrong way again. I think that's it. Yep. Now I'm going to do the same for the top end, which is 1.5 megahertz, and tune up to 1.5 megahertz. It's actually spot on 1.5. Now I just have to adjust for maximum AF voltage again. That's it. It's pretty close. In fact, I think it was spot on. So, what have we achieved? The AM, for the AM we've done the long wave oscillator tuning, adjustment, and the front end. Medium wave we've done the oscillator and the front end. Now all we need is shortwave, and shortwave is the problem because I'm not getting anything. So what I'm going to do is I'm going to try it, see what shows. Okay, here we go. 6 megahertz. That coil is difficult. Okay. That looks right to me. That's where it's staying. Time for the 7 megahertz point. The 7 megahertz point is actually a bit, well, it's not that far away, but I'm doing it in steps. I'm going to set it closer, adjust, and then set it finally on the 7 itself. Okay, that's in the right direction. Move it a bit closer. There we go, nearly there. One bit more. There we go. That's it, 7 megahertz, spot on. Well, I did the alignment of the front end for the shortwave. Wasn't too complicated, nothing new, but I lost the footage. But now, it's got to the point where this video is going to go on for ages, so I'm going to stop here, and I guess the next one will be the last, because I've still got quite a few things to tweak here. I've got to just calibrate the meter. It's going on the negative end down too far, and a few odds and ends, and I'm thinking about what to do with the FM, how much alignment I'm going to do on the FM, because it takes an enormous amount of time just to set things up and tape it, and anyway, we'll see. I'll see how I feel, but it's nearly there. I just want to show you something. I made a mistake when I said there was no shortwave reception. I think it had to do with the time of day that I was checking on it. There was absolutely nothing on the dial. And when I think about it, it's not too surprising. I was doing it in the middle of the day, and I normally don't get much below 10 megahertz in the middle of the day anyway. And the top end of this is 7.4, 7.5. So it was probably doing what it's supposed to be doing. But let me show you what we're getting here. This is on long wave, And I don't know if you can hear that too well, but that sounds like it's a local station, and it certainly is not. There's not much on long wave anyway, but that is incredible.
Reconstitué par son fils Gunther. Costa Brava, le 29 septembre 1959.
I think that's BBC 4 or something from the UK. I sometimes get it a little bit better than this, sometimes worse. But it's there. And of course, the local beacon. Let's try medium wave. North Africa. Our local station. That'll be Canary Islands. A lot of these from now will be Canary Islands. That's North Africa as well. This is a station that actually appears quite a few times on the band, so I'm not surprised. It's from the Canaries. And now, the big surprise with shortwave.
Et oui, c'est pour cela que cette semaine, nous allons partager avec vous pas moins de 6 témoignages, dont un fait par audio, car oui, désormais, vous pouvez... Qu'est-ce qui fait que ce retour s'est fait là aujourd'hui?
Il n'y a pas de consensus aujourd'hui.
So, shortwave is there. It's pretty strong as well. I'm actually very pleased because I was pretty worried about this. It's a very simple front end for the shortwave. I knew the oscillator was working, so I couldn't figure out why I wasn't getting anything. And I guess it's because there wasn't anything to get. Anyway, folks, this has been a long episode, and I'm still going through parts of the service manual and making the corrections that a couple of people have sent me. I'm hoping that in a couple of days I'll have the whole thing done and I'll be able to come back and wrap this project up. It's been going on for quite a while. It's beginning to feel like the lockdown project, and I didn't really want it to be that. Anyway, I want to thank you for watching. Hope you've enjoyed that. If you have, please share, subscribe, like, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now, and stay safe.